Going into a new chapter, we're going to do some topics from chapter 4, starting with section 1 on exponents. These are the objectives, and we're going to move on. Exponents. Well, keep in mind that exponents are a kind of shortcut way to indicate multiplication and refer to, let's say we have the number 3 and the exponent is 4. The 3 is considered the base. This is background. And the 4 is the exponent. Now, what does this refer to if we're saying shortcut? Well, it's saying we're going to take our base and multiply it by itself the number of times the exponent indicates. And that's what this is. So the basic background for exponents. Now, one of the techniques we're going to talk about, and write this down too, the product rule, is if our bases are the same and we're multiplying the bases that are the same by exponents, like so, the product rule is, we just keep our base and we add our exponents, and this will give us then 8. Now, there is a rule for this that I also want you to include, and we'll raise this up so you can see the rule to include it. And it's this, and I'll write it bigger for you. A to the m times a, again our bases are the same, equals a to the m plus n. And again, this is background. So, for example 1, we're going to have an A, B, C, and D. That's all worked out for you. So I could write it out, but you can just copy it down into your notes. I'd copy this down. 3 to the second times 3 to the third. You can kind of skip this step. Write this, and then simplified is this. Now for B, you'll notice we have 6 to the second times 6. Now there is no exponent initially on this part, but any number or variable has an exponent of 1 that is usually not written. So this would become 6 when you add your exponents to the third, which simplifies to 216. Now, as we look at example C here, it's in 2 parts. Well, in the product rule, we're going to multiply our numbers. 7 times negative 3 is a negative 21. And then we add the 2 and the 5 gives us y to the 7th. And again, they're showing you an intermediate step that you don't have to write, but kind of know what's going on. And then this is the answer. And then the last one for letter D, you're going to go 3 times 2 is 6. X to the second, x to the third gives you x to the 5th. y to the third, y to the fifth gives you y to the eighth. All right, I think something relatively simple. Again, this is referred to as the product rule. Going on to background now, the rule for the exponent of 0. So if you have a number like 5 to the 0 power, what does that equal? Well, generally speaking, anything to the 0 power is 1. So we see as background here, this is going to be 1, and then, well, when it's simplified, 5 to the second is 25, so 25 times 1, this would simplify to 25. And they're not quite asking for that yet. I'm getting a little ahead of myself. Here they're just keeping this as the 0 exponent. Now, this gets a little tricky, and I'm sure they're going to show it to us here in a moment. But if we have negative 5 to the 0 power, now you might think that this is a 1, but it's not, because the exponent only applies to the base. So we would think of something like this as a negative 1, which is in a sense out here, times 5 to the 0. So 5 to the 0 is 1, times a negative 1, this becomes a negative 1. Now, again, give you background, if you had something like this in parentheses, because now the base is negative 5. Here, the base was only the 5, not the negative, because it wasn't included. Here, because of the parentheses, it's included. This is a 1. So a little subtly again, I'm sure they're going to show us here, but repetition is good. And here it is for example 2. So for A, you're going to write 7 to the 0 power is equal to 1. That's straightforward. Now here, because the base, because of the parentheses, is a negative 5 to the 0 power, this is also a 1. Now we see what I talked about in D. We'll get to that shortly. Now, for C, our base is, because of the parentheses, 8x to the 0. So anything to the 0 power is 1. Our base is the 8x. And they're giving the qualifier that x could not equal 0, because if it did, then that wouldn't be the answer. Now, here, again, let me stress that. This is negative 3 to the 0 power. What is the base? Is the base negative 3 or just 3? And the answer is just 3. You can think of this as a 1 here times that. Now, they're not showing it that way, but that's the way you can think of it. So 3 to the 0 is 1 times a negative 1 gives you a negative 1. And that's what they're showing. Good. I think repetition is good. Now, for background, again, you're going to write the quotient rule, where we have 4 to the 5th divided by 4 to the 3rd. Now, in the product rule, if we're multiplying, we add. In division, it seems reasonable that we're going to subtract. So the general rule is you bring the exponent up from the denominator, crosses the division bar, and the sign of the exponent changes to a negative, and we get 4 to the second, which would be 16, and they're working it all out for you. So again, the rule is a to the m, write this down, a to the n, the exponent from our denominator comes up, and you get a to the m. As it crosses this division bar, the sign of the exponent changes, and you get the quotient rule. Okay, so example 3, letter A, copy this down. Now the answers are all below, but we'll work it. Remember there's a 1 there. So as that 1 comes up, it'll be 7 minus 1. This will be x to the 6th. Now this is sort of interesting. When that 2 comes up, you get a negative 2 there. So this becomes y to the 0. And what is anything to the 0 power? 1. Now notice, if we had y to the 2nd divided by y to the 2nd, we say anything divided by itself is 1. So this is sort of the proof of the 0 power. Now for this one, you're going to divide a negative 3 into 12 and get a negative 4. Bring the 3 up, subtract it from 12, and you get x to the 9th. So again, things relatively easy as long as you know the protocol. 2 goes into 14 7 times. Now this is y to the 1st, comes up as a negative 1. This gives you x to the 9th then. 4 comes up as a negative 4, y to the 2nd. So again, the quotient rule. Now in this next part, we're going to take a look at what is called, for background, negative exponents. So let's just give some general definition. So if we had a to the negative 2, if we wanted to have positive exponents, keep in mind there's a 1 there, and then everything is over 1. Now, if we wanted this to be a positive exponent, that same rule applies. We would take the exponent, the 1 would stay up on top, our base would come down, but what would happen to our exponent sign as it crossed the division bar? Well, again, the sign would change, and this would become that. So let me just clean this up a little bit. This is equivalent to this. And they work it out here as well. And write the rule for negative exponents. The rule is a to the negative n becomes 1 over a to the n. As the exponent crosses the division bar. Here they're not showing this extra stuff I put in. Becomes this. Okay, now for example 4, you want to write these out, and you want to end up with positive exponents. So y to the negative 3 becomes 1 over y to the 3rd. Now here, again, you want your exponents to be positive. This is going to be, since this is a 6, this is going to be 1 left up in the numerator, because there's a 1 there. The negative 6 comes down, becomes a positive 6. So this then will become 10 to the third. And if they want you to simplify, this is 1 over 1,000. Again, if they want positive exponents, take a moment to copy it down. This will become x. So this is a 1 there. This is 8. So this would be x as an intermediate step to the negative 2 after we do the product rule here. And then bringing it down to our denominator, x to the second. Because generally we want positive exponents. Now for letter D, let me clear this up here. Now you can go 2 times 18, or you can cancel this 3 with the 18 and get a 6, because these are factors. You can cancel out common factors. So 6 times 2 is 12 for the numerator. Now I have a, let's just have an intermediate step here, a to the 10th, all over a to the 15th. But you need to do some simplification. This is 12 that remains there, but we're going to bring the 10 down, subtract it from the 15, and that gives us a to the 5th. And if we move it up here, we see our answer there. Okay, now keep in mind, you can always look at lesson or learn yourself. These are there. And there's also videos by the author there, but these are my notes and what you are to copy into your booklet. Remember, watching, listening, copying, the best way to hopefully develop mastery. Now, as we go to this rule for power rule, and write this down as background, the power rule for exponents. And this could be shortened here a little bit. Let's see. If we had 3 x to the second, but now all of that is raised to, let's say, the 3rd power. Now, what does this mean? Well, it means we're going to write this 3x to the second three times. Now, because of the parentheses and then something raised to the power, this is the base. But you might say, do you just add here? Or is it something different? Well, let's get this answer. 3 times 3 times 3 is 27. Now we add up our 2's and we get x to the 6th. So the answer is you wouldn't add, but keeping in mind that 3 has a 1 there, so this would become, in a sense, when we apply that power to what's here, it's going to be 3 times, up in the exponent, 1 times 3, and x to the second times 3 in order to get our answer. So in the power rule, it unfortunately begins with the letter P, the same as product, so it can be confused. Students wonder, do I multiply, do I add? Well, for the product rule, you add. For the power rule, this is our illustration, you're going to multiply. And the rule is down below here, and we see it, and then they're just giving you a summary. So add this rule, and I'll make it big for you. a to the m, now raise to a power. Here we're going to have a to the m n. That is, we multiply as opposed to add. Okay, let's have some practice on this. And then so as we do example 5, again, you're going to write this down, letter A, and it's going to be y to the negative 12, the power rule. We can't leave it that way, so this will become 1 over y to the 12th. Now for letter B, we're going to cube a negative 2, which becomes a negative 8. There's a 1 there. So this will be x to the 3rd all over y to the 6th, 2 times 3. Now for this one, and I'll clear that up so we can see it better, we're going to square the 3. Well, let me write this one out because there's a couple of things you can do here. Now there's 2 ways to do this. You could actually expand all of this and then do the canceling. Or before you take it out of the parentheses, you could do some canceling. So this can be simplified. Here, 2 is going to be subtracted from the 3, so you're left with an a on the bottom. Here, this b to the 1st can be subtracted from that, so you end up with a b. So this is what you're left with here. So much easier. 3 squared is 9, and then this is going to be a squared, b squared. Now, had you expanded all of this, you would get a rather complicated thing that you would then have to simplify. So let's take a look at what they're showing us too here for that letter. And you see they get the same answer we got, but they didn't simplify first. So you could do it either way. All right, let's go on. Now, this next part is background, and it's a little rule that goes like this. A over b to a negative n power. Well, if you'd like your exponent here to be positive, all you have to do is take the reciprocal of what's here, which would be b over a, flipping that, and then your exponent becomes positive. And that's what they're showing. Okay, include that. That's a good look. And for example 6, we'll work this one out for you in some detail so you can see how the protocol would be. Go to our whiteboard, and we're going to first flip this. So this will become b to the 3rd in the numerator and a negative 3 a to the 2nd in the denominator, but this now becomes to the 2nd power. Okay. So now we're going to do this. It's the product rule. So on our numerator, we come b to the 6th. 3 times 2 is 6. Now, when we square a negative 3, it becomes positive. So this is 9. And then this becomes a to the 4th. And they're giving a lot of work on the original. Hopefully, seeing it done this way makes it a little easier to follow. Okay, go back, and there is our answer. Now, this is our last example, and they get rather complex. So you can see the discussion of this is complex. I'm going to put this on the whiteboard for you, and hopefully you can follow it. Okay, rather than try to write this out as I talk, I worked it all out, and let's see if we could follow it. Now, what we did is I simplified what I had here. I brought this x up, subtracted from that, got x. Brought this y up, became y to the fifth and my 3. So I just simplified internally and got this. Now here I did the same. I brought the negative 5 up. This becomes x to the 7th. The 4 stayed there. Brought this down and became y to the 4th and kept the exponent outside. Then to change the exponent from negative, I just flipped this, or took the reciprocal, and made the exponent positive. And the same thing here. And then I just didn't write the 1 because we don't write the 1. Now, I expanded this. 3 to the second is 9. And then x to the second, y to the 10th. Just kept this. And then now we use the product rule. On the top was 9. But now I had x to the second, x to the 7th became x to the 9th. And I took the y to the 4th, the 4 down, subtracted it from the 10, and got y to the 6th. And I'm saying, wow. All right, that's my work. And then this is what the others had. Remember to keep our answer. And there's our answer, 9, 4, x to the 9th, y to the 6th. And you'll see the many steps they did. Again, there are different ways to do it, and this should wind us up. This was a tad long, but again, lots of stuff.